Okay, so in the last session, what did we do? Flex VPN, right? Today, let's start with the SSL. Yesterday, I gave you a task, right? The task was, first is, what is SSL? What is SSL VPN? Correct. SSL Handshake. And then SSL Tankless VPN. And then we have SSL thin client. This thin client is not really being used, okay? So we'll not see this implementation. Kind of port forwarding only. And then we have SSL full client. This is known as full client or thin client, same thing. So, did you do the research? No. Okay. I think basic difference you already know about, site to site VPN and then remote access. What are the differences?
And in branches, we have to use side to side, and remote access, we have to connect bank to phone.
Branch with home.
We have to work from home. Yeah.
Work from home. So site to site VPN generally is used between two sites. When you have two or more sites that wants to communicate with each other, that means branch to branch communication you need. In that case, we will go with site to site VPN. Okay. And when a remote user wants to communicate with the organization network, okay, when a remote user wants to communicate with the organization network, in that case, remote access VPN. Let's say, for example, for site to site, we have taken so many examples, right? You have one site, you have another site, and then they are connected via internet. You have internet in between. This is internet. Site 1. This is site 2. So in this case, what will happen? A tunnel will be established, right, between these two sites. Okay. And your traffic will pass through the tunnel. So like this, the tunnel will be established. And also what is going to happen here, that in this case, if we talk about the public IP here, let's say at the source, as well as destination. So both of these IPs, these are static or dynamic. These will be static, fixed IPs will be there. Okay. And in this case, the tunnel negotiation, who will negotiate the tunnel setup? Who will negotiate? So at these two sites, we will have edge devices, routers, or firewalls. So those devices will negotiate the tunnel setup. Okay, not the clients who are working in this organization. You can consider one site as like this is your site 1. Okay, then this site might have an edge device, let's say a firewall or a router, anything you can consider. This is the edge device. Then after the edge device, they can have a switch. Okay, and then they can have inside different networks and PCs and departments, all of these things. Okay, So who will negotiate the tunnel setup? Tunnel setup will be negotiated by this edge device, which is really connected to the internet. Clear? Okay. Then you can say like these are connected like this. Okay. Now we have one switch. Just a temporary example we are considering. So this kind of setup is. So who will negotiate the tunnel setup? The tunnel setup will be negotiated by this STVs. And same way on the other side also, other side is also going to have some sort of setup. And there also the tunnel will be negotiated by the edge device. In this case, your internal devices that are present in the organization, they are not going to initiate any sort of tunnel setup. These are not going to negotiate a tunnel setup. And also these guys, they will never be aware of a VPN configuration. They won't be aware of a VPN configuration also. Why? Because whenever this particular site wants to communicate with the other site, automatically this edge device will do the tunnel setup. So according to them, they are connected to the other site directly. They will never know that their traffic is passing via the internet or the ISP. This is your site-to-site VPN. Now, in case of remote access, what can happen? That you have a user who wants to work remotely, okay, like work from home kind of concept. So this guy is also connected to the internet. This is, let's say, no user. And this time what will happen? That this remote user now, he might be working from anywhere. Okay, he might be working from anywhere. Could be bus station, railway station, airport, or anything, friend's house, his own house, anywhere he's working. So depending on that, here the source IP, this will be the source. Okay, so the source public IP, correct. So we'll say not fixed. This is not fixed. It will depend. Okay. Then depending on he wants to connect with site 1 or site 2, let's say he is an employee of site 1. So for this guy, this will become destination. Okay, this will become what? Destination, and destination is already having a static fixed IP. Now what? In this system, there are few possibilities. Okay, there are few possibilities. What are the possibilities? One possibility is that he might have a client software installed. He might have a VPN client configured. This guy might have a VPN client configured. So he might have a VPN client software configured. So that VPN client software will do what? Will help this remote system to connect with the site. Okay. And the tunnel setup this time, it will be done here. Directly to the site. So whatever the traffic of this user will pass, that traffic will pass via the tunnel. Okay. So this is one way when client will be required. So if client is being required here, in that case, what kind of VPN it will be? This will be full client or client-based VPN. SSL client-based VPN. Now another way is, see, there can be devices where you do not need configuration of a client. Okay, in which you do not need configuration of a client. Okay, so in that case, without VPN client also, we can go and communicate. Remember, if you if I show you clientless VPN examples, okay, your clientless VPN is also known as, if we talk about your SSL clientless VPN, this is also known as web VPN. Okay. This is also known as certificate on web browser. That means HTTPS you are accessing right now. So that is one way. Another way, companies are also using the web VPN or the client-less VPN. Okay. Or another name we can call it as a browser-based VPN. We can also call this as a browser-based VPN. So see, if you remember, like organizations are also using the web-based VPN, and in which case they are using that I'll explain. See, we don't require right now. Now here, see, normally if I search, no, this is advanced Google IQ. See, all I'm trying to show you is that this is how organizations are using. So what organizations will do, they will give the public IP to the remote user, okay, and then they will give this URL. Now what? The user will decide, okay, that how they are authenticating, and based on that, the user will be provided with the username and password. So user will give username and password, and they have selected the domain, and after that, they will click on login. So once they will click on login, after that, what will happen? They will see a web page. In that web page, the IP address or the URL of their internal server will be there. That means now this user can directly work with the internal server. That means what is the case? Understand this scenario, how it is. Let's say this is our site. Okay. In this site, I have, say, one firewall as my edge device. Okay. Then I have my internal network. And let's say I have one server in the DMZ. Okay. This kind of setup. Okay. Now see, from this firewall, this server communication will be there. Okay. But in the firewall, I have created a rule that if somebody directly tries to access this server, that communication is not allowed. That means by default, outside to inside, entire communication is not allowed. Okay. But also I have created a rule that, okay, if the traffic is coming from a specific IP range, that has to be allowed. Okay. So whenever a remote client will try to connect, let's say via the internet, a remote client will try to connect. This is a remote client. Okay. So whenever a remote client will try to connect, in that case, first of all, what will happen? The traffic will end up where? From here to internet, internet to firewall. Now, once this traffic will end up at the firewall, so he will have his public IP, correct? And then after, he will connect to the firewall using the public IP. He will get the URL. Once the user will provide what? The username, password, and then he will log in. After that, what is going to happen? That the user is going to get a URL. Okay. The user is going to get a URL in the, there will be a web page. Okay. After this, there will be a web page. So the first thing the user got is what? The first page the user visit is the login page. Okay. Once the user will provide correct username, ID, password, credentials, he will be redirected to another page. He will be redirected to another page. In this page, what will be there? There will be a URL. URL of internal server. Okay. And when the user will click on that URL, that request will not go from user's IP address. That will go from the firewall's IP address. And this communication is allowed. That means here, this firewall will act as a proxy also. Okay. This firewall will act as a proxy as well. Then response will go where? To the firewall only. Then firewall will send this response here to the user. This is how the web-based VPN will provide communication. No, this URL, this one. No, this will not change.
Someone is copying and paste and give access to someone else.
How? They cannot give, right? Because this URL will be what? It will be just like, let's say, for example, this is a server that has an IP address, let's say 10.1.100, and here HTTP service is running. That means port number, it is open. So this URL will be what? Something like 10.1.100, and here it will be something like HTTP colon double slash. Now, if somebody will copy this URL and try to connect also, it doesn't matter, because this is a public IP, private IP. So no communication. ISP will not allow any communication. And then in this firewall also, we have created a rule that do not allow any communication from any other IP. If it is coming from local IP, then allow it. Okay. So this way, this communication will be provided. Is that clear? Okay. Now, see, when it comes to remote access VPN, we have two types again in the remote access also. In the remote access, we have IPsec VPN also, and we have SSL VPN also. Okay, in both remote access VPNs are available. IPsec, we already know if you are using IPv version 1 9 message exchange. Okay, IPv version 2 4 message exchange. Okay, and SSL is what we have to understand. So let me open it. Okay. So IPsec and SSL, remote access VPN. This is the agenda about IPsec or SSL, then IPsec, and then SSL. So first of all, let's talk about IPsec versus SSL. So there are some features based on which we can differentiate between your IPsec VPN and SSL VPN. So first of all, let's talk about client software. So your IPsec VPN, they will use Cisco VPN client software for complete network access. Now IPsec is going to allow all the IP-based protocols. That means all the protocol communication. Once the tunnel is established, all the communication will be allowed. Correct? But when we talk about SSL VPN, it will use a standard web browser to access limited corporate network resources, because only web-based applications will be allowed. Other applications will not be allowed because we are accessing through the browser. So whatever the applications like FTP, HTTP, whatever is supported in browser, those things you can access. Other things you cannot access. So if you want to provide limited access, in that case, SSL VPN, and in SSL VPN, you eliminate the need for separate client software. But in IPsec based VPN, we require the client software. Okay. When it comes to management, so we must install and configure a Cisco VPN client. Without that, no VPN. And in this, we do not need to install a VPN client. No configuration is required on the client machine. See, a user doesn't require any configuration. He just need a web browser and type that URL. That's it. Then he will connect to the VPN login page. He will type the username password there. Again, he will get a URL and he will go to the next machine. And this is how he will be accessing. When it comes to encryption, so IPsec based VPNs, we have seen that DAS, 3DAS, AES, SHA, MD5, all these protocols are supported for integrity and confidentiality. In case of SSL encryption will be there because this is native to the web browsers. Okay. Then if we talk about applications like where it will be supported, so your IPsec will encapsulate all the IP protocol, including TCP, UDP, ICMP, whatever it is. But your SSL VPN supports limited TCP-based client-server applications in the clientless mode. But if you are using AnyConnect, in that case, that is the full client VPN. So encapsulate all the IP protocols. This is clear? Okay. Then cost-wise differences. IPsec is free license, and SSL, you must purchase a license depending on what kind of service. So there are different types of license like AnyConnect, Essential, Premium, Mobile, and Shared Premium. Then user environment. So your IPsec is suited for permanent or full-time telecommuters. That means if you have a huge amount of traffic passing, in that case, you can go with the IPsec. But if you are going with the SSL, so when you can go with the SSL, suited for all types of user, including contractor, temporary workers, and even full-time workers. Then if we talk about connectivity, so establish seamless connectivity to the network. Okay, we have seen in the site to site that we have full communication, correct? And it support application connectivity through browser product. How AnyConnect works? In AnyConnect also, we will just type. If you, I'll show you that here. There you'll see a picture of the AnyConnect also. Okay, so it's coming. Wait for it. Now see here. So here SSL VPN will support application connectivity through the browser portal only. And workstation. So IPsec, only 32-bit Windows operating systems are supported. Okay. So because it was used in the old technology like your easy VPN, but now it has been overcome. So now we are, if you are going with the SSL, then 32-bit or 64-bit Windows operating systems are supported. Okay. Then after deployment considerations, so client workstation, like what you have to take care of before deploying IPsec or SSL. So client workstations, you have to check. What you have to check? Are the client workstation company owned? That means are they company systems? Okay. Will the user be connecting the internet kiosk or guest machines to the network? Will the user be using mobile stations? These things we have to check about clients. So depending on, see, that sometimes in organization, what happens, either the organization will provide you the laptops, or sometimes they will ask you to bring your own laptops, right? Bring your own device kind of concepts. So these considerations as a security engineer, you have to take care of. That whether the client will be using mobile, okay? Then will the user be connecting from internet kiosk? Maybe he will be working from in some internet kiosk or something. Or will the client use company system? Okay. User type. So do you want to deploy the remote access solution for contractor or part-time employees? That means who will be like freelancers, you can say. Okay. And do you currently have a software deployment solution? Okay. Sometimes what will happen, like in case of remote access VPN, we have something called as like Cisco secure desktop or secure desktop access. Okay. So that kind of concept will be there. So do you have a deployment solution that will deploy the software also in the client machine, right? Because if sometimes what will happen, let's say when you connect to a remote access VPN, SSL VPN, so the SSL VPN, or let's say, for example, I configure SSL on ASA. So now in ASA, we will have certain packages for Linux machine, for Windows machine, and for Linux machine, Windows machine, and Mac OS. Okay. Now, depending on through which operating system you are accessing, they will say, okay, this is your application, download it. Certain times you try to download application, automatically they will detect your operating system and they will say, this is your download. For example, like if I right now go and try to say any desk, okay, see here. So it will give me a download now button. If I click on download, see, automatically it has selected my correct. So this is also available for all different operating systems, right? This is also available for all the different operating system. So this is how we are talking about that to deploy these softwares, to show these softwares, do you already have a deployment solution, software deployment solution? Then about connectivity, are whatever the applications you want the remote clients to access, are they all browser based? If browser based, then you can go with the clientless VPN. Okay. Do you want to provide full network access? If you want full network access, in that case, you will have to go with the full client based VPN. Okay. Are residential broadband providers blocking and or charging more for IPsec traffic? Sometimes happens that whatever the internet service provider is there for you, they might charge extra. But right now we don't have this case. Okay. Are remote access users coming through NAT routers? Again, is there any NAT device in between? So all these considerations we have to check. Then accordingly, we have to select our VPN. Okay. Now, when it comes to IPsec, okay, so in IPsec, we have seen that there are two phases. There will be two phases. So the user will be using a VPN client software, and let's say ASA is there. So who will initiate the tunnel setup? Not ASA, the remote user. So who will be the initiator? Your client will be the initiator, and ASA will be the responder. So then, first of all, IC version 1 will go, phase 1, phase 2 IPsec, and then finally your data. Then we know that in the phase 1, we have main mode and aggressive mode. Okay. And in the phase 2, we have quick mode, right? So each phase has its own security association, and the security association in the phase 1 is known as ISACM, and in the phase 2, IPsec ASA. Correct? Then next is what? This is phase 1.5 where the authentication thing happens. Okay. That means between these two. Aggressive mode, we don't really care about. These are the negotiations. Okay. We already know about the negotiations between your main mode and quick mode, right? So let's not go with these things. This is quick mode negotiations. No, graphical configuration. Don't worry. No comments this time. In SSL will not configure comment. You can do it using comments also, but since you have graphical facility, why to go with the comments? Okay. So ASA also we will use ASDM. We will use ASDM for VPN configuration. Okay. So let's go with the remote access SSL VPN. So first of all, SSL. So SSL is a protocol that was developed by Netscape for secure e-commerce communication. Okay. And what it does, it creates a tunnel between the web browser and the web server. Okay. And it is authenticated and encrypted. And for this, it uses algorithms like RC43-DES and AES. Okay. So the capability is shipped by the leading browsers, and they are using what? Certificate, right? So certificates, again, we have two types. One is a self-signed certificate and CA-based certificates. Okay. So in the HTTPS, what is this S? The closed lock also indicates what? that it is SSL enabled, and the port number that it usually uses is 443. Okay. Then we have clientless, thin client, and client based. Okay. So clientless means basic web-based access will be there. You will have email access. This is Windows file sharing, CIFS. Okay, this access will be there, and here you can show customized user screen. Okay. Then after, in the thin client, this is just normally a port redirection or port forwarding concept only. Okay, not really being used right now. Then we have client based, where we have a client software like Cisco, AnyConnect will be there. Okay, so here we will be using what? Cisco AnyConnect, and with the help of AnyConnect, we will connect to the organization network and we will have full network access. Okay, so as if we are in the local network itself. Okay. So first of all, clientless VPN. So this is the customization, like this is the web page that will look like. If you look here, once you authenticate on the login page of the VPN, this is kind of page you are going to get. That's Cisco Web VPN service. And here we will attach all the bookmarks like this. Those bookmarks will be shown. These are the URLs. The user will just come and just click here on these bookmarks, and relevant application they will access. Okay. And all these things are customizable. You can see customizable banner graphic. That means here, instead of Cisco, you can show your organization picture. Okay, you can customize the banner messages. You can customize the access methods, customize links or network resources, localization, advanced customization. Everything you can customize in this page. Okay. Then this is the configuration. So here you can see the configuration is using your that means basically the configuration, it is happening using ASDM only. Okay. See here, this is the ASDM wizard. Okay. So the configuration will be, see, it will be like total 6-step configuration. You see here, step 1 to 6. So total 6-step configuration will be there. You just have to select whether you want to configure clientless or Cisco AnyConnect VPN client. That means client based. Okay. So right now, let's say if you're going with the clientless, in that case, what? You just have to give the connection name. That means this is the profile name on which interface the remote user will be connecting. So outside interface, you can see here. Okay. Now, if you want certificate-based authentication, then you will check this. If you don't want it, leave it. Okay. Then connection group alias or URL. So what is the URL you want to create? So let's say my ASA IP is 10.1.1.10 or outside IP is 11.1.1.10, right? So what will be my URL? 11.1.1.10/VPN. This will become my URL. Okay. Or you can use this also. Simple 11.1.1.10 also, that will be what? Normally in the ASA, if I give the ASA IP address, what it will show me? It will show me the web page to download what? To download the ASDM application, right? ASDM application. But once I configure the SSL VPN, then after it will not show me to download the ASDM application. It will show me the URL to access the VPN service. Okay. Then after, once I configure all these things, I have to decide how I want my authentication using AAA I want, or I want using local user database. So initially we will go with the local user database. We'll create a username and password and we'll add the user. Once we have added the user, next step is what? You will create a policy that, okay, who is accessing? In organization, you can have different, you can say like different department users you can have who are working remotely. So for them, you can create group policies. Okay. Once you create the group policy, after that, you will start adding bookmarks. So what are the bookmarks? See here. Do you see web bookmarks, file folder bookmarks? We will start adding these bookmarks here. So you will click on manage, click on add, then bookmark list name. What is the name? And then here, what will be the title? Okay. So here internally, what is the server IP address? That server IP address I will give here. Okay. Then once this is done, our VPN configuration is done. Okay. After this, It will be confirmation what you have configured. Okay, and this will be the CLI configuration if you are looking for comments. So these are all the comments. Okay, so either you type all these comments, and we have done in 6 steps in the graphical. Whatever seems easier and better to you, you can go according to that way. Okay, and once this is done in, then we are good to go. So anytime if you want, we can go and edit the bookmark list also. Okay, so ASA version 8.0 and later supports a number of common client server application via Java plugins such as Windows Terminal Server, Telnet SSH, Citrix ICA Client VNC. That means these protocols are also supported. Okay, through the web only. Okay, then the resource is defined as a URL in the appropriate protocol type like RDP : FTP : VNC : Okay, normally we say HTTP : So like this, the particular resource will be given. Okay. Then after, support for third-party application exists in the form of package single archive files like .jar files. So again, if you want other protocols, third-party applications, then the file format should be what? .jar, Java-based application. Okay. Then like this, all these things will be shown. You can see like HTTP, HTTPS, CIFS, FTP, RDP, SSH, Telnet, VNC. These are different protocols. Okay, so you can see that when clicking on a resource link, a dynamic page is generated that hosts the ActiveX or Java applet, and the Java applet is rewritten and resigned. ActiveX parameters are written. Why ActiveX is required? Because sometimes maybe you will have, like, you might want to take access of an application that is giving you some graphics. Okay, so this ActiveX will do what? It will support the graphics, give you smooth graphics. So that's why it will be required. Okay. Then the Java applet is transparently cached in the gateway cache. Okay. Then virtual keyboard feature also can be provided, so that to avoid key logging attacks, virtual, this online keyboard or virtual keyboard can also be provided. Okay. Then if you want double authentication or two-factor authentication, we can enable two-factor authentication also. Okay, so we can configure secondary authentication method. So either you can use the comments, or else we always have option in the ASDM, in the configuration, in the AnyConnect, we have secondary option. Here you can define your radius server, give the server group, and select option. You can attach if you have a AD. Okay. Then you can just start debugging, and you can check whether AAA status is accepted or rejected. Then you can debug the radius server. Command will be debug radius. So these are some of the commands only. Okay. And if you want to test your connectivity with the AD, again, within the ASDM itself, we will have the options. Okay. In the AAA setup, AAA server groups, we will have here option to test. Okay. So we can test the ASA connectivity with the ASD, AAA server or your AD. And these are few more comments if you want to debug, like NFS share, WebVPN NFS, WebVPN CIFS, WebVPN Citrix, WebVPN JavaScript. Okay. Then these are some of the show comments, like show WebVPN statistics, show WebVPN group alias. One of the common command that you will be using to check the configuration, okay, or statistics, this is the command, show VPN session DB summary. This is the command mainly you will be using, that how many active clients are there, SSL VPN clients, how many clients, total clients, how many clients. Okay. So like this, you will be seeing. So this is the command that you should make note of. Okay. And next is about your AnyConnect client. Okay. So if we talk about your AnyConnect client, This is also known as thick client, full tunneling, or tunnel client. These are some other names. So traditional style client delivered via automatic download. Like I said, this client software will be given as for download. Okay. This requires administrative privileges for initial install only. That means whenever in the Windows we try to install a software, we always get a pop-up for administrative permission, yes or no. Correct. Then pre-deployment of MSI package is available. It can use TLS or DTLS as transport, can be upgraded from a previous version of upon connection. That means in the firewall later on, if you upgrade the VPN client, so automatically it will be upgraded in the remote user. And you can create client profiles for personalization and user configurable preference for local LAN access also. That means these are all the features of your Cisco AnyConnect VPN. Okay. This is how the old Cisco AnyConnect looked like. Okay. This is how it was looking old. So there are two ways. One is web-based. So in the web page, you will get Cisco AnyConnect, and from there you can use full network access also. And another one is pre-deploy. That means within the client system, it will be installed. So this was the old Cisco AnyConnect VPN client. And if you want to look at the newer one, see here. Cisco AnyConnect. Look at the images. This is how the newer one looks like, or this image you can. These are all the same. This is how it looks. Okay. So all you have to do, just type in here the IP address of your, that means there will be the public IP address or domain name given to you for accessing your organization or connecting to your organization. So just you have to type it here and you have to connect, and then automatically it will connect. Okay. So this is the newer one. This is clear. Okay. Online people, clear. Now, next thing we have to understand about is your SSL handshake. Let me go get some water. Okay, time बचेगा. Okay. So, handshake. Intents do not show. You open the book only. This is one book that I'll share. Bulletproof SSL and TLS.
More than 500.
Yes.
For them.
You are studying 5,000 pages. What is 500? The protocol.
531 pages. 31 again.
Now see here. Step-by-step process. There will be a client and a server machine. The first message will be what? Client, hello. Okay, always first message hello to check whether the neighbor is available or not, or the peer is available or not. So client will begin a new handshake and is going to submit its capabilities to the server. Now, what kind of capabilities the client will be submitting here? See here how this is client hello message looks like. In this message, the client will be telling about its cipher shoots. That what are the encryption method, hashing methods it is supporting. These all informations your client will give. Okay. Then what are the signature algorithms it is supporting? Okay. So all these informations client will give in which message? The first message itself. Okay. So it will begin a new handshake and it will submit its capabilities. That these are all the things I am supporting. Now what? Server will select connection parameters. Okay, same like that. Initiator will do what? Initiator will send the proposals that, okay, these are the encryption algorithm, hashing algorithms I support. And server will do what? Server will say that, okay, I will be using this one. This is clear. Now, server will also send what? Certificate, key exchange, and server hello, done. So server will send its certificate chain. Okay. Then after, depending on the key exchange, server will send additional information required to generate the master secret. Because here also for encryption, okay, for encrypting the communication, what will be used? A key will be used. Okay. So to generate that key, server will send some additional information. Okay. Then after server will indicate that my message, hello message have been completed. This is clear?
Yeah, certificate.
Certificate. Okay, for this you need to understand PKI. In the cryptography, I have explained, right? PKI. Which type of certificate? See, whenever let's say, for example, you want to have communication over the internet, so you will have a public key and private key. Now, how our browser is making a decision here? How my browser will make a decision that this website is secure or not? So what this server is doing, when this server is sharing the certificate, okay, when the server is sharing this certificate is signed by a certification authority private key. Okay, this certificate is signed by CA private key. Okay, so now this certificate will come to the client. Now what the client is going to do? Client is going to first see, do I trust this? This particular certification authority, do I trust? So how browser will come to know whether I trust or not? Because in your browsers, if you check, in my browser, if I go to the settings and if I say certificates, so you see authorities, my browser is trusting all these certification authorities. So if there is a certificate that is certified, that is signed by these certification authorities, if there is a certificate coming to me that is signed by these certification authorities, that means I trust the certificate. And in the certificate, what will be there? In the certificate, there will be the public key of the server. What it will contain? It will contain the public key of server. Is that clear? And then server will also exchange additional information like key exchange information, like Diffie-Hellman key exchange you can understand here, using which they will generate shared secret. Okay, this public key is different, and whatever the key exchange will be done, that will be different. Okay, so this is, you can see like this is a optional message. Given a star, optional message. Okay, so now client has received what? Public key of the server. Now, whenever client will send anything, let's say, for example, client is exchanging the keys, okay, or is cipher specifics, then client will encrypt that traffic using this public key. Client will encrypt that traffic using the public key of the server. Server has the relevant private key, so only server can decrypt this. Okay, so this is how it is happening here. See here. Now, next is what? Your client is going to send additional information required to generate the shared master secret. So that means this is kind of Diffie-Hellman only. Okay. Yeah, they are sharing the public keys, then they will add their own private keys, and that will give the master key. Correct? So they will get the same keys, and then client switches to encryption and it will inform the server. Message number 7. That client has started encrypting the traffic. Okay. Then after, client will send a MAC of handshake messages it sent and received. Okay. Then after, server will also switch to encryption and it will inform the client that, okay, I have also started encryption, and then server send the MAC of handshake message it received and sent. Okay. Now, if you look at these messages, this is the first message, client hello, in which the cipher shoots are given by the client. This information is given. Okay. Then after, this is the server hello message. The purpose of server hello message is for the server to communicate the selected connection parameters back to the client. Client has shared so many. See how many shoots it has shared and how many algorithms it has shared. But now server will select only few. That, okay, this is the cipher shoot I will be using, and then these are the extensions. Is that clear? See here, message number. You need to understand. See, that MAC is which message? Message. One is last, client shares first, right? 8. Okay. Okay. Server hello, server key exchange finished. Authentication request session key exchange. That we have many key exchanges there. Electrical authentication. This MAC is different actually. This is not the MAC address we are understanding. This is abbreviated. Certificate request authentication. No, this is different MAC algorithm. Yeah, it has to be. Handshake. This is not the MAC address. This is the algorithm actually. Okay. This is not the MAC address. This is the algorithm. Okay. How to check now. Okay, look at the messages right now. In the server hello message, it is selecting what? A cipher sheet. Okay. Out of many algorithms, it has selected one. Then the certificate. Okay. So the certificate will be carrying what? It will be carrying the public key of the server. Okay. So you can see the server must ensure that it sends a certificate appropriate for selected cipher sheet. For example, the public key algorithm must match that is used in the sheet. Okay. Then key exchange is there. So the purpose of key exchange message is to carry additional data needed for key exchange. And the contents will vary and depend upon the negotiated cipher sheet. That means what are the negotiated cipher sheet? You are using RSA with AES 128 GCM and SHA-256. This is the same thing if you will see here. Let's say any website you are visiting. And if you look at this, here we are getting that AES 128 GCM SHA-256, 128 bit is key length, and then TLS 1.3. So see here, there is one more thing that we have SSL version 1.0, 2.0, and 3.0. 3.0 is more secure. Okay. And your SSL version 3.0. Okay. SSL version 3.0 is also known as TLS version 1.0. Okay. After 1.0, we have 1.1, 1.2. And right now, which one is being used? 1.3, which is the highest, which is having the highest amount of security. Okay. Advanced version of SSL. Okay. That's why we say that, okay, SSL security or SSL VPN, but actually right now encryption protocol is what? TLS. And TLS 1.0 started is what? SSL 3.0. Okay. That is different. Even there is one more misconception or one more confusion keeps on going. What is that? That when you will study about SSL, okay, some people will say that at which layer SSL VPN will work. Now, here is the misconception. Okay, not a misconception, but there are different theories. Because see, you are using what? HTTP, HTTPS. Which layer protocol? Application layer. But encryption, decryption happens at which layer? Presentation. And the use of VPN is what? maintaining end-to-end session. Which layer? Now, no, session. Session layer, right? Maintaining the sessions. So, session layer. Now, what do you will say? So, all three are correct. Why? Because currently we are using what? TCP, IP.
That's why how they are in
Application layer. Understood? According to TCP IP, this is application layer. And see, in OSI model, we cannot say that, okay, if a protocol is working on layer 7, that cannot be there on layer 6. Why? Because OSI model is just a logical framework, conceptual framework only, right? That is just telling you the things that is happening at each layer. But it is not telling, it is not the real science that how the device or the protocol is working. A protocol might be working on multiple layers. Is that clear? So here, according to TCP IP, you will say that this works on application layer. Is that clear? Okay. Now let's look at the images. Different places. Maybe they have SSL 1.3 switch. Now see that here it's clearly mentioned. So first message is what? Client hello, and this message lists the client's capabilities so that server can pick up the cipher shoot that the two will use to communicate. Okay, and this will also include a large randomly picked client number that is also known as client random. Same way, server will politely respond with server hello message, and in this message, server will tell the client what connection parameters it has selected. Okay, and then it will return in its own randomly selected. That means one randomly large number client will send, another randomly large number your server will send. Okay, this will be known as what? Server random. Okay, then after, if the client and server they are not exchanging any capabilities, that means not sharing any cipher shoots, then the connection will terminate unsuccessfully. Now third is what? Third message, server will share the certificate. So in the certificate message, the server will send SSL certificate, which includes leaf certificate and intermediate certificate to the clients. That means it will send its own public key, basically, you can understand. Okay, to provide authentication to the connection to SSL certificate signed by the CA. Okay, so they will take a certificate from the CA. Then after this will allow the client to verify that the certificate is legitimate, because in the browser, there is already a list, and you can see like right now I'm visiting this website, I have this lock symbol. So it says that the connection is secure. Now, why it says connection is secure? Because it has been verified by which certification authority? Kaspersky Lab. Now check whether they might have Kaspersky. Affirmative assumption. Name of the certification authority. No option to search. But if your browser does not trust the certification authority, in that case, normally we get the error that connection to this website is not secure. Do you still want to continue? Those kind of errors will be there. Okay. Upon receipt, the client will perform several checks to authenticate the certificate. This includes checking the certificate's digital signature, which is signed by the CA. So whether the client is trusting the CA or not. Then verifying the certificate chain and checking for any other potential problem with the certificate data, like whether the certificate expired. Because whenever you talk about a certificate, look here. Whenever you talk about a certificate, in the certificate, always there is an information that the validity of the certificate is that this certificate is not allowed before 15th March 2024 and it is valid until 25. So that means these kind of parameters it will check. Okay. Then after, it will check whether expired certificate or wrong domain name is there. These kind of parameters will check. Then the client will also make sure that the server has the possession of the certificate's private key. Okay. So this will be done when? During the key exchange and generation process. That means when they will exchange the keys. Okay. Now, number 4, this is an optional message. Message number 4, that is key exchange. So this is an optional message only needed for certain key exchange method like Diffie-Hellman, because they will share. They have to calculate a shared secret for the secure communication. Okay. That requires server provides additional data. And then finally, server message, hello message done, tells the client that it has sent all the required. That means whatever the things are required, it has sent. Message number 6. Message number 6 is what? Client is sending the key, right? So the client then provides its contribution to the session key. The specifics of this step depend upon the key exchange method that was decided in the initial hello message, that what algorithm they are going to use to exchange the keys. Okay. In this example, we are looking at RSA. So you can here also, you can see like what was the method being used. Method being used was RSA. Okay. So the client is going to generate a random string of bytes called pre-master secret and then encrypt it with the server's public key and transmit it. Now, only if the server is having correct private key, then server will be able to decrypt it. Otherwise, server will not be able to decrypt it. Okay. Then the message number 7, change cipher specification message lets the other party know that it has generated the session key and is going to switch to encrypted communication. Now, client has shared in the key exchange, client has shared what? Its own key, whatever the key the client has generated, and then encrypted the key with the public key of the server. Now, if the server has the correct private key, server will already know the public key of the client. So that now whenever server has to send any message, server will encrypt. And when client will send, client will encrypt with the server's public key. And then with the message number 7, client is telling the server that, okay, I am switching to encrypted communication now. Message number 8 is the finished message is then sent to indicate that the handshake is complete on the client side. Okay. And the finished message is encrypted and is the first data protected by the session key. Whatever the session key they have decided, using that key, it will be protected. Then the message contains data that allows each party to make sure that the handshake was not tampered. That means there will be some data. The algorithm, MAC algorithm was there, right? Which shows that, okay, this message contains a data. So there will be a random data that will be showing to each party that the communication was not tampered. Then after server's time. So what server will do? Server will also send, right? That means server will also tell that, okay, I will also switch to encrypted communication now. So now it's server's turn to do the same. It will decrypt the pre-master secret and compute the session key. And then it will send its own change cipher spec message to indicate that it is also switching to encrypted communication. And finally, the server will send the finished message using the symmetric encryption key that it has generated. And it also perform the same checksum to verify the integrity of the handshake. Okay, and this is how the complete handshake process will be there. Clear? So many things happens between the server and client. And we can also find something like packet capture. I think I might have it. So packet capture. Here it is coming with an MTLs.
Oh, CCI is down there.
Guys, Monday holiday.
Oh, आप ही बोले सर से हर चीज की छुट्टी देंगे तो एलेन बंद ही रहेगा हमेशा। अब मैं अच्छा हो पता बता मैं तो मंडे को बैठ लेके आ जाता ही।
Okay, guys. So Monday is holiday. Now you have 3 days weekend. And we have one less session we have for weekend. So this is clear. One less session we have. Like we would have 5 sessions. Now we'll have 4 sessions. We are not the packet capture. SMB TCP. Now you can see here that we have here, this is client hello. This is the client hello message. And in this message, handshake protocol, see, client is sharing the cipher shoots. Okay. Along with it, client is sharing the signature algorithms. Okay. Hashes, these are the signature algorithms it is supporting. Okay. Now, out of these two, right now you can see we have these two only. Two cipher shoots we have. One is RSA with AES-256 GCM with SHA-384, and one is renegotiation. These are two. Okay, now when server will click, so server has sent the RSA with AES-256. Okay. And here server is saying that server hello is done. Okay. Before that, server is also exchanging Diffie-Hellman. So they are using what here in this case? Diffie-Hellman for generating the key. Okay. So server key exchange is there. Server is also sharing what? See here, the certificate information. Correct. This is the signed certificate. Okay. This is SHA-1 with RSA encryption about the validity of the certificate. Okay. That this is the not before. This is after that, how long the certificate is valid. So all this certificate information as well as key exchange information, okay, and hello done. These three things will be shared in one message. See, here it is separately showing, right? These three informations, if you see. So these three messages, server hello, certificate, key exchange, and hello done. These four messages are showing separately, but it's actually one message only. So total messages 1, 2, 3, 4, and 5. These are the total 5 messages. Okay. Now see here. Then next is what? Client key exchange, client chain cipher, and then encrypted handshake message. Okay. After that, we have new session ticket, chain cipher spec, and encrypted handshake message number 4. And then finally, encryption alert. This is the message number 5. Total 5 messages. So in the client side also, you can see client key exchange. Okay. Then client is saying that change cipher spec. So now client is saying that, okay, now I will use what? Encrypted connection. Okay. So now everything is encrypted. Here we cannot see the information. Okay. If we look here, in this message, we don't see anything. Only client is sharing what? Diffie-Hellman parameters. Now, server has shared Diffie-Hellman parameter. Client has shared the Diffie-Hellman parameter. Then they will add their, see, in the Diffie-Hellman also what they have shared. Public key. So both have shared their public keys. Then they will add their relevant private keys and they will get a common key. Which one?
22 and 22 and then
Where do you see? This is the size. Okay. This is clear. Now, you know, like when we talk about Diffie-Hellman and all, so we have group numbers. Okay, those things. So this is the length of public key, 65 bit. Okay, then the length of key exchange message. Then this is the TLS length, which is 70. And what is the TLS version they are using? 1.2. Okay. So this is how it is. Then we have new session. This is sent by the server. Okay. So now server has also sent the chain cipher spec. That means server will also shift to encrypted connection. Okay. And this is encrypted handshake message. And once this is done, then this is last message, which is showing that, okay, handshake has been completed. Okay. So these are the messages. So total 5 messages actually are there. But here when explaining, it is showing so many, 10. Okay. All right. Now, next thing we have to see is we have to see the configuration of clientless VPN in the ASA. Okay. So we'll use the ASDM for that reason. Okay. Process, we have already seen that how we will be configuring. Okay. Step-by-step process we have seen. Total 6 steps are there. Okay. Total, these 6 steps are there. That we will go to our ASDM and then we will start configuring with the 6 steps. Clear? So this we will do in our next session. So we have lab will not be created, otherwise we can do it. No, will not. If required, we will take it on weekend. Okay, because we'll take enough time, no problem. Okay, then that's it for the day.